Welcome to this fascinating journey into one of the greatest mysteries of all time, the origins of the universe. Have you ever asked yourself, how did the universe begin? What triggered the Big Bang and what existed before space and time? These are some of the most profound questions in cosmology, astrophysics, and theoretical physics, capturing the curiosity of scientists, philosophers, and explorers throughout history. In this video, we will explore key scientific theories that explain how the universe came into existence. We'll dive deep into the Big Bang theory, widely considered the leading explanation for the universe's explosive birth, approximately 13.8 billion years ago. We will also discuss the puzzling nature of dark matter and dark energy, which together make up about 95% of the universe's total mass energy, yet remain largely mysterious. Moreover, we will examine cutting-edge ideas like the theory of everything, an ambitious attempt by physicists such as Albert Einstein and modern thinkers like Brian Greene to unify all fundamental forces of nature into a single framework that could explain the universe from its very beginning to its ultimate fate. Throughout the video, we will highlight the contributions of famous scientists and visionaries, including Stephen Hawking, who advanced our understanding of black holes and cosmology, Carl Sagan, who popularized the wonders of the cosmos, and Einstein, whose theory of relativity revolutionized how we view space and time. Whether you are passionate about space exploration, quantum physics, or simply curious about the story of existence itself, this video will provide a clear and detailed overview of the biggest questions in universe origins research. So, stay tuned as we unravel the enigma of the cosmos and journey through time, space, and the incredible science that reveals how everything began. The Big Bang theory stands as the cornerstone of modern cosmology and the leading scientific explanation for the origin of the universe. According to this groundbreaking theory, around 13.8 billion years ago, everything we know, all matter, energy, space, and time, emerged from an incredibly hot, dense, and tiny point called a singularity. This event triggered a rapid expansion, often described as a massive cosmic explosion, which scientists call the Big Bang. One of the strongest pieces of evidence supporting this theory is the observation that the universe is still expanding today. This was first discovered by Edwin Hubble in the 1920s, when he noticed that distant galaxies are moving away from us, and the farther they are, the faster they move. This phenomenon, called Hubble's law, suggests that the universe was once compacted into a much smaller, hotter, and denser state. Another critical discovery is the cosmic microwave background radiation, detected in 1965 by Arno Penzias and Robert Wilson. The CMB is often described as the afterglow, or fossil radiation, from the early universe, a faint microwave signal that fills all of space. Its existence provides compelling evidence that the universe began in a hot, dense state and has been cooling ever since. Despite these successes, the Big Bang theory leaves some questions unanswered. For example, what caused the singularity to begin expanding? What happened in the moments immediately after the Big Bang, often called the Planck epoch? And what existed before the Big Bang? Or did before even exist? To address some of these questions, scientists developed the concept of cosmic inflation, a period of extremely rapid expansion within the first tiny fraction of a second after the Big Bang. Proposed by physicist Alan Guth in the 1980s, inflation theory explains the large-scale uniformity of the universe and why it appears flat. Prominent scientists like Stephen Hawking and Roger Penrose also contributed ideas about the nature of singularities and the origins of time and space itself. Hawking famously said, "Time itself began at the Big Bang," so asking what happened before the Big Bang is meaningless in the traditional sense. While the Big Bang remains the most accepted model, it is important to remember that scientific understanding evolves with new data and theories. While the Big Bang theory is widely accepted, several alternative theories and models exist that challenge or expand our understanding of the universe's origins. One of these is the cyclic universe model, which suggests that the universe undergoes endless cycles of expansion and contraction. Instead of having a single beginning, the universe might be eternally reborn through a series of big bangs and big crunches. Another fascinating idea is the multiverse theory. This theory proposes that our universe is just one of many, possibly an infinite number, of universes existing simultaneously in a vast multiverse. Each universe may have different physical laws, constants, and even dimensions. The multiverse concept arises naturally in some interpretations of quantum mechanics and string theory. Additionally, quantum cosmology attempts to apply principles of quantum mechanics to the entire universe. This approach tries to explain how the universe could have originated from a quantum fluctuation in a vacuum, essentially, how something can emerge from nothing due to quantum effects. Theoretical physicists like Brian Greene and Roger Penrose have explored these ideas extensively. Penrose, for example, developed conformal cyclic cosmology, which suggests that the universe's lifespan is a series of eons, each beginning with a Big Bang-like event. These alternative models highlight how the origin of the universe remains one of science's most profound and open questions, pushing the boundaries of physics and philosophy alike. Max Planck is considered the father of quantum theory, a revolutionary field that changed our understanding of physics and the universe. Around 1900, Planck introduced the idea that energy is not continuous, but comes in discrete units called quanta. This concept laid the foundation for quantum mechanics, which plays a crucial role in modern cosmology and theories about the universe's origins. One of the key ideas connected to Planck's work is the Planck time, which is the smallest meaningful unit of time, approximately 10^-43 to the minus 43 seconds after the Big Bang. Scientists believe that before the Planck time, the laws of physics as we know them break down, and quantum effects dominate. This period marks the limit where quantum gravity theories must be applied to understand what happened in the earliest moments of the universe. Planck's discoveries also lead to the idea that the universe might have emerged from a quantum fluctuation, a spontaneous event in the quantum vacuum, where particles and energy briefly come into existence. This challenges classical notions of causality and before the beginning. Modern physicists, including Stephen Hawking and Brian Greene, build on Planck's quantum insights to explore ideas like quantum cosmology and the theory of everything, efforts to unify general relativity and quantum mechanics into a single framework explaining the entire cosmos. Understanding Planck's contributions is essential to grasping how physics attempts to explain the universe's mysterious origins beyond the Big Bang. When we look at the universe, everything we see, stars, planets, galaxies, and even all living things, makes up only about 5% of the total cosmos. The rest is an invisible mystery, dark matter and dark energy. Dark matter is a form of matter that doesn't emit or absorb light, making it impossible to see directly. Scientists first noticed its presence when they realized that galaxies rotate much faster than they should if only visible matter were present. Dark matter acts like an invisible glue, holding galaxies together through its gravitational effects. Yet we don't know what it's made of. Is it composed of unknown particles like WIMPs, weakly interacting massive particles, or something entirely different? This remains one of the biggest questions in modern physics. Dark energy, on the other hand, is even more mysterious. It is a form of energy that seems to be driving the accelerated expansion of the universe. Discovered in the late 1990s through observations of distant supernovae, dark energy now accounts for about 70% of the universe's total energy content. It acts like a repulsive force, countering gravity and pushing galaxies farther apart. Both dark matter and dark energy challenge our understanding of the cosmos. They suggest that the universe is not just what we see, but is largely shaped by invisible forces and components we barely understand. As Neil deGrasse Tyson once said, we are living in a universe that is mostly unknown, and that's both terrifying and thrilling. These mysteries might hold the key to understanding how the universe formed, why it expands the way it does, and even what its ultimate fate might be. The theory of everything, often called the Holy Grail of physics, is an ambitious attempt to combine all the fundamental forces of nature, gravity, electromagnetism, the strong nuclear force, and the weak nuclear force, into a single, all-encompassing framework. Such a theory could explain not just the large-scale structure of the universe, but also its birth and the behavior of the tiniest particles. This quest began with Albert Einstein, who spent the last decades of his life trying to create a unified field theory. While he made monumental contributions with general relativity, which explains gravity and the curvature of spacetime, he could never merge it with the strange world of quantum mechanics, which governs subatomic particles. Modern physicists like Stephen Hawking, Brian Greene, and Michio Kaku continue this pursuit. String theory and loop quantum gravity are among the most popular candidates for a theory of everything. String theory, for example, suggests that all particles are tiny vibrating strings rather than point-like objects, and that additional hidden dimensions exist beyond the 3 dimensions we know. Why does this matter for the origin of the universe? A true theory of everything could explain what happened at the very beginning of time, during the Planck epoch, when both quantum effects and gravitational forces were infinitely strong. It could tell us why the Big Bang happened, what caused the expansion of space, and perhaps even answer the ultimate question, why there is something instead of nothing. As physicist Brian Greene once said, the theory of everything would give us the deepest possible understanding of reality, the very code of the universe. Beyond scientific models and theories, the origin of the universe leads us to one of the deepest questions ever asked. Why is there something rather than nothing? While physics explains how the universe evolved after the Big Bang, it struggles to answer why the Big Bang happened in the first place. Philosophers and scientists alike have grappled with this mystery. Stephen Hawking once said, "Because there is a law such as gravity, the universe can and will create itself from nothing." But what does nothing mean in this context? In quantum physics, nothing is not a complete void. It's a quantum vacuum filled with potential energy, capable of giving birth to particles and even entire universes. Others argue that this question may never have a satisfying answer, as it touches on the limits of human understanding. Carl Sagan famously reminded us, "The cosmos is within us. We are made of star stuff. We are a way for the universe to know itself." From this perspective, exploring the universe is not just about answering scientific questions. It's about understanding our place within it. This philosophical dimension of cosmology makes the study of the universe's origins both scientific and deeply personal. It invites us to look not just at the stars, but within ourselves, to question the nature of reality, time, and existence itself. Even with all the progress in cosmology and theoretical physics, there is still so much we don't understand about the origin of the universe. The Big Bang theory explains how the universe expanded and evolved, but it doesn't tell us what triggered the Big Bang. Was it a quantum fluctuation? Was it part of an infinite cycle of universes being born and dying? Or is our universe just one small bubble in a vast multiverse? We also don't fully understand dark matter and dark energy, which together make up about 95% of everything. What are they made of? Why do they behave the way they do? These questions could completely rewrite our understanding of reality once answered. Another unresolved mystery is the unification of general relativity and quantum mechanics. Gravity governs the large-scale structure of the cosmos, while quantum mechanics governs the smallest particles. Yet they don't currently work together in one single framework. A theory of everything, if discovered, could finally solve this puzzle. As physicist Neil deGrasse Tyson put it, "The universe is under no obligation to make sense to you." But that's what makes science so thrilling. The unknown pushes us to keep exploring. The origin of the universe remains one of humanity's greatest unsolved mysteries. From the Big Bang to the theories of dark matter, dark energy, and the theory of everything, each discovery gives us answers, but also raises new questions. Perhaps the ultimate truth about the cosmos is something we can only glimpse, never fully grasp. Yet this pursuit, the search to understand where we come from and why we exist, is what makes science and human curiosity so extraordinary. As Carl Sagan once said, "Somewhere, something incredible is waiting to be known." What do you think about the universe's origin? Could the answer be hidden in the mysteries of quantum physics, or is there something beyond science waiting to be discovered? Share your thoughts in the comments. If you enjoyed this journey through space, time, and existence, don't forget to like the video, subscribe, and turn on notifications for more content on cosmology, space exploration, and the deepest questions of science. See you later, take care, goodbye.